So Mpini was basically looking at this paper here, which is on 3D face recognition. Most successful, currently successful facial recognition algorithms are focusing on 2D images rather than 3D facial recognition. Cameras, I mean, human beings, as you move around in front of a camera, you are in 3D, isn't it? But if a camera takes an image, most cameras are basically 2D. The resulting image is 2D, except more modern phones where you can take a panoramic picture. Those that can you turn around in order to take an entire picture of your surroundings. That has got the impression of a 3D, isn't it? But when you are a human being, you are a 3D, isn't it? And you could look at spatial features that indicate some 3D elements. So you would expect the algorithms for 3D facial recognition to be slightly different. So it's quite interesting that this paper is reviewing 2 decades of research in that area. And of course, they specify in their abstract that their objective is to stimulate future research in the area. And so they are basically conducting a comprehensive review of the progress achieved within these last 10 years. But they focus not only on deep learning, there are deep learning methods and also traditional approaches. So, and one of the things they do is to compare results by using publicly available data sets for facial expressions, pose variations, and what they call occlusions. So it's if you want to go into the area, it's a good paper for that. Actually, I picked quite a number of papers which I circulated across the groups for people to volunteer to take. The idea is that since the majority of people are still looking for research problems, you might actually find a problem of interest. I don't particularly see a scenario where just browsing through his slides, he has got an introduction where he sort of summarizes some of the things. Right. But 3D techniques are a little bit different. In other words, you'd have a 3D model of a person and see if you could recognize that particular person. I think 3D information is more detailed, of course, but it's also more complex in terms of if you are to come up with an algorithm for that. So that's quite an interesting area. Of course, if you look at the challenges, of course, the benefits are quite clear, isn't it? There is enough sufficient geometrical information, and of course, you have some degree of invariance to various eliminations, because a 3D model sort of your face doesn't change that much just because there is a light present or anything like that. So it's much better. It doesn't, whereas a 2D model, depending on the light, some parts of your face may be hidden, isn't it? Based on lighting. So the 2D models have got a problem. And also, you have enough information to be very accurate in terms of facial expression. But there are challenges, of course. Here, he has identified those according to that paper. And I think the paper they give also some kind of a classification of 3D facial recognition algorithms. You can see they are landmark-based, cave-based, local page-based, holistic, and of course, deep learning. Of course, interesting. Of course, there is papers like these. Obviously, they have to perform some form of comparison. Yeah, and future directions in terms of what research could be required. He identified four of them, isn't it? The bridging the gap between 3D face recognition and generative AI. And then developing a foundation model for face recognition, such as one with NLP, advancing development of NLP technologies. It's like trying to take the approach to map what happened in another domain to this particular domain. I wonder whether there's no foundation model so far. But of course, they did have a literature review, so it seems there is a lack of a foundation model of some sort. Have solutions that are consistent even with poor quality 3D data sensors. Yeah, that is important. Usually when you are trying, especially if your data collection surface is massive, you need to then to collect data from multiple points. So the challenge is that if some of the sensors die or for some reason are not functional, can your algorithm still work with fewer sensors? It also reduces cost as well. So that is a very important area of research where you try to come up with quality solutions with poor quality 3D data sensors. Then last one is more attention should be given to data sets with various types of occlusions, because that's now a very technical term. What are occlusions? Yeah, you need to be in the image processing domain to know that. So it's a very interesting area for those guys who want to go into facial recognition algorithms. Right. Papers are like these also teach you how to do a literature review, which is one of the things I was thinking. I've been thinking of coming up with in fact, I will create a video on how to do a literature review. But taking a look at this, let me stop sharing and share the actual paper itself. See if I can share the paper. Right. You can see this paper, isn't it? If you look at, when you read papers like this, you also learn how to do your own literature review, and it's very important. Let me see if these guys, if I can get a menu, an outline of this document. These tools really do outlines, isn't it? Get an outline, bookmarks, nothing. You only have that. I cannot find a topic outline for that. So maybe let me just leave it like that. But if you look at this paper, you will notice that one of the most important things when you do a literature review is to define your review framework. For instance, here is summarizing the contribution of this paper itself. A review, obviously, as a review, it's a contribution on its own. It can be used to help a reader understand the history, status, future of 3D face recognition. So that's more or less a contribution. It also talks about a comprehensive review of both traditional and image in deep learning based algorithms. Yeah, obviously that's a contribution for them. And it also look at the discussion of the approaches. In this case, different nuances that are faced by 3D face recognition, including facial expressions, pose variations, and occlusions, and a comprehensive comparison of existing algorithms on several publicly available datasets. Right. So it's important to set out to be able to identify some of the things that you will contribute, but above all, a research framework is very important. Maybe this one, let me see if they come up with this. In this case, it's difficult to get an outline for this paper. Maybe it's because the tool I'm using doesn't extract whatever that comes up, data sets, terminology. Anyway, in this case, they don't explicitly specify a section where they indicated data sets. So to me, it's not, it may be poorly written in that sense, but according to their case, you might be able to think that they are using these 4 aspects as their guideline for the rest of this article. Yeah. For instance, if you look at the organization, say they describe the basic background, terminology, and pre-processing approaches for images, for 3D images, and then a comprehensive survey of existing 3D face recognition methods, deep learning methods, and comprehensive comparison of existing algorithms under the different variations. Right. So it's a very, I don't consider this to be a very good, a well presented. The review itself is good. It's a good literature review, but it's not well presented, mainly because they don't have a review framework. But I think they are guided simply. It's a very simple literature review with minimal high level thinking and organization as well. Because all they are doing is to compare the traditional methods. They review the traditional methods, and then they review the deep learning methods. And after that, they just compare the various algorithms. And interestingly, I'm not sure whether in their section, let's start by looking at their section. Pre-processing approaches, that's not a very interesting section in this case. But what might be interesting are section 4 and 5. Especially those ones, and let's see how they come up with this. Is section 3. Section 3, where does it start? Right, section 3 is on pre-processing, so we need section 4 really to see how they present it. But ideally, I don't find this paper to be, I've passed already the beginning of section 4. I don't find the literature review to be well organized. I wouldn't use it to teach someone how to do a literature review, because they have done initially very little thinking after their literature review. Right. For instance, here he simply start by saying landmark-based algorithms and all that without laying out a proper framework. Although he may have classified them, but you need to present your classification and rationalize why you classify them the way they are. For instance, the first sentence is, according to facial representation type, these geometry-based 3D face recognition algorithms can further be classified into landmark-based, curve-based, local page-based, and holistic methods. Right, and then all he does is to pick each one of them and then review or compare some of those algorithms. But this section assumes that we already have read before about these geometry-based 3D face recognition algorithms. I am assuming that probably he may have covered them somewhere, which to me doesn't make sense, because previously he is looking at learning-based, he pre-processing, isn't it? Which means I don't expect him to start making me understand what geometry-based 3D face recognition algorithms are Of course, he has got a terminology section. One expect that he would have covered it, define what these are at that point. And also, this section, he is covering traditional approaches, isn't it? That's what he said in the introduction. But is not really, but here he's focusing on these 3D geometry-based 3D face recognition algorithms. How are they related to traditional whatever approaches? So it's not a well-written literature review, according to me. You could have done better by setting out your review framework first and categorizing them and justifying why the E has got this. Why is E based on geometry-based 3D face recognition algorithms? But according to the introduction, this is where he covers traditional approaches, because he is distinguishing between traditional approaches versus deep learning based approaches. And then section 4 is for traditional approaches, and section 5 is for deep learning based approaches. But when you come to section 4, he does not, his introduction even doesn't talk about the traditional approaches, traditional based methods. What he could have done is to say, okay, maybe give us a clear picture of what falls under his traditional approaches. And I'm assuming this is landmark based, curve based, and all that, or rather geometry based, isn't it? What about, are there any methods that are not geometry based? And why is he leaving them out? Or is there nothing else except geometry based? All these questions are not quite clear from that. So it's not a very nicely presented, although I could say it's good work. If ACM accepts it, it means there was valid work there. Now let's look at his section 4. Here, obviously, he listed them at the beginning in the first sentence of the introduction, section 4, and then he picks each one of them and just reviews that, which is a little bit simpler and a little bit naive as well. Right. Now he's giving all these are what section 4 holistic algorithms. Notice that I don't think he listed holistic algorithms. Did he list that in the introduction? Maybe not, but you do find them here. Right. Now next to section 4, 5. Right, that's where he covers deep learning, facial recognition. But in general, yeah, for instance, initially he talked about 3D based, and then he talks about holistic methods. But then he did not clearly lay them out from the beginning to say, okay, what are your classes? You have traditional based approaches, some are geometry based, some are holistic or whatever, and then come up with a proper classification. And then you go on to expand on that. So a review framework is very important. It makes your work much easier to follow. So here he covers deep learning. Obviously, deep learning is now being used everywhere. There's a lot of training data. Deep learning based methods have shown remarkable performance in 2D face recognition because of lack of large scale 3D face data sets. Obviously, most cameras don't take 3D. So a 3D camera is just difficult to come across. So chances are that 3D data sets are very limited. And therefore, you don't expect a lot of algorithms that are 3D based. Makes sense? So that's interesting. As we categorize these methods into methods with learning based on 2D representations, learning based on 3D representations, and learning based on disentangled representation. This is where you probably look at 2D faces. It's very difficult to see what that does would be, but at least he classified them here. And then after that, he picks each of them and goes on to review all those. Probably there's better organization around in this section 5. But section 4, I'm still doubtful to say, okay, he has section 4 is a little bit difficult because he talks of this geometry based. Most of them will be geometry based. I don't know whether there are other geometry based. So I don't think this one is well described, this section here. Yes. But all he does is, so these are geometry based, he goes on to cover them in that order. Right, I have a young one here. Hi, how are you? Right. Let it come in once. Right. So it's a fairly simple technique. You can even picture it in your head how he has structured this literature review. Then after that, he then simply conduct a discussion. I think it's section 6. Section 6 is then when he does a discussion. Comparative results under pose variations. He now looking at algorithms and compare them under various poses. Of course, what you may think, how did he do it? How do you compare under different poses? He may have to extract the data from the literature. This is what seems to be the case. To say, to look at papers that have reported each facial expression and look at the percentage and then create a table like this. Because you can see these are citations, these are methods that he has already covered. And then the various citations, and then seeing the reported performances for each of them. So that you can come up with a visual sort of representation of these various formats. Of course, most of them you can see that there are very high levels of percentages, which is in the 90s. So I wonder whether this is very useful in one way or another. Rather than performance, it is using performance, but then these are reported performance, not his own. Maybe when you are designing a literature review instruments, especially on comparison, you may want an element that is determined by you, the reviewer, rather than the reported aspects, which is quite interesting. Of course, comparison like this could be quite good, but there should be another way of comparing, which you yourself determine more or less. So that's what he's doing in section 6, comparing these and evaluation results on the covered data set. The other way in which you could do this is to actually implement each of these and then run the data sets against all these. I'm not sure whether he did that, or he is looking at several papers that uses the same data set and see how they compare and extract results from the papers themselves, which could be interesting. If you find papers like this, 1, 2, 3, 4, 5, 6, 7, all using the same data sets, you would be lucky. It would be maybe in images you could assume that you find a lot of papers like that. And after that, he does a conclusion. Right. In the conclusion, one of the things that you would expect is the future work. This is what a doctoral student might be interested in, or any researcher. The future work is where they list what are the possible research that can come out of this. Right. Here, based on these observations, which he has summarized above, several promising directions are worth considering for future work. And then that's where the ones he lists. if you look at this sometimes and you look at the year, this is only October last month, 2023. It means no one has picked up these problems, isn't it? Right. For instance, bridging 3D face recognition and generative AI. In other words, you want to look at no one. In other words, he's assuming, or he has found out that no one has applied generative AI algorithms to 3D face recognitions. Generative AI is more like even the ChatGPT algorithms, like ChatGPT, right? So that could be quite useful. Already, I think generative AI is creating faces, human faces, automatically. Generate a face, and it comes up with a complete face. So we already have generative AI that is capable of generating a human face. But the question in their finding is that they haven't applied it to 3D facial recognition. Leveraging a foundation model for 3D face recognition. Yeah, a foundation model. Foundation model dominated the research of natural language processing and shown promising potential in computer vision tasks. With the help of multi-modality foundation models, it is possible to boost performance of 3D face recognition. That's a new area of research. So all these, potentially, if you look at the year when he proposed this, no one has really picked up this yet, or people are only beginning to pick up that now. So if you do pick it up at this point, you are fairly safe. So at least that's my analysis. And there, look at their literature. They've cited up to 249 papers. I don't particularly think that it's very impressive. This has been done by these guys from China mostly, and one guy from this guy is likely to be an Arab, but based in Australia. The rest are China, right? Yeah, you would expect that. There isn't, yeah, of course, given that it was accepted by ACM, you would think that it's a good result, but I'm not particularly very well impressed with the way they presented their work, given that these are Chinese with very limited English language capabilities as well. Their case is just a question of saying, okay, we want to do a literature review and 3D face recognition. Our literature will be divided into two traditional approaches, deep learning approaches, and then after that, we compare the performance of these algorithms with respect to specific data sets. What I'm not sure is whether they implemented each of the algorithm and ran it over the data set. Of course, some people do that in a literature review, but you need a year or year and a half to do that. So it could be that someone was doing a PhD. If that was the case, then they did a very good job of it. If the first author is a student, then that could be interesting. That could be interesting, but you can always find out whether this guy was a student. For instance, here you would find out that this. I'm not sure whether you guys can see this. I'm looking at the first author's location. Let me share this. I don't know whether I should share something like an entire screen. Right, if you look at his this guy is an author, and yeah, he's got a good number of publications. But interestingly, he has just a name and no institution associated with him, which is quite interesting. But he has got a a website which a link which leads nowhere. Right. So it's like he did his PhD or he's got a number of publications. But otherwise you can find him online. Computational visual media is obviously in the area of visual media, and he has published quite a lot in that area. So I'm not quite sure whether he is a student or he's not, because his ID doesn't say much. It doesn't say much. But generally, Sun Yat-sen University, in the National University of Defense Technology. So he is based at these two institutions in China, and this guy is in Australia. It's possible that he was supervised by this guy in Australia before he went back to China, under those other things. But it's it's a very simple to understand literature review, not that complex. Of course, the nuances, if you are now starting into this research, it's a good start. So for someone who want to look at facial recognition and want to look at 3D approaches, you have a very good summary of the entire domain. The structure of the literature review itself is simple, it's not that complex, although you could have done better by putting a classification framework, especially earlier at the section, or even have a section where you say, okay, 3D facial recognition is divided into two: deep learning and traditional approaches. And then under that, you also specify which ones are they, and then generally justify that sort of classification and explain why you are classifying it that way and why it's the ideal, why you are adopting it for purposes of this research. It's more like a methodology for this particular paper. But obviously he didn't do that. That's what I would recommend for most of my students to say, okay, sit down and think. You need a literature review as well to do that, come up with that classification. Like in his case, you can't just say, there are two approaches, deep learning and traditional approaches. And why are these traditional? Why do you call them traditional? And then after that, you then say, all these traditional approaches are geometry based. That's what he did. They're geometry based, but without explaining why do you say they're geometry based? Are there others that are not geometry based? Or it's just all of them are geometry based? We need that information. I'm not sure whether he did that. He explained that. But looking at the structure, you have terminology and data sets. Here you're covering the data sets for the images, which is comparing with later on in the section on comparison. And then he covers the terminology. That's where you find some of the terminologies. Not much. Just covers a small paragraph on terminology. Receiving operating characteristic. I think he's also using the wrong term, wrong word here. It's a receiver operation characteristic. If, and then the false rejection rate, a false acceptance rate, and all these other terms. That is not much terminology there. In terms of data sets, is simply picking major 3D face data sets. Yeah, and those are the major ones that he's comparing with. Of course, he could easily, given this large number of data sets, you can easily pick a number of papers using all of these if they are public. So it's fairly easy. And he's covering all the data sets and then goes on to do some pre-processing. Once the 3D face is obtained, pre-processing is required to make the 3D face suitable for face recognition. Typical pre-processing operations include nose tip detection, data filtering, and pose normalization. Yeah. And given that, it's interesting. I'm not sure why it was necessary to cover to cover pre-processing here. Because the focus really is on 3D face recognition, and pre-processing is not that much a big issue here. Yeah, I'm not sure why he focused on that. He could have focused more on his classification, why classify it that way, and why your literature review is structured that way, and so on. But the paper is good. If you are into 3D face recognition, you have a clear information about the domain. You also have an identification of the various areas, and that would be great. Right, that's all I can say about this. At least I'm not speaking like someone who's reading, and I'm also speaking like a teacher who wants to teach literature reviews or how to read and analyze papers like these. That could be quite useful. Right, I will stop sharing. I don't know whether I can successfully do that. Right.